Hi and welcome to this guide about absolute heights when working with a rotary laser or levels in general. It's very good to know that this section assumes a basic working knowledge about a rotary laser, and I've made a different guide to see that section about lasers in general. Before we can use the laser properly and to its full potential, it's very necessary to have a solid understanding of absolute heights. And the key point from this lesson to take away is that a higher number on a drawing is further up than a lower number. And it's not more complicated than that. It's as easy as it seems. So here's that picture of a mountain. If a stick figure would be standing on top of the mountain, it would be perhaps 1500 meters above sea level. If he would be standing here, he would be 700 meters above sea level, and here he would be 500 meters above sea level. In a drawing, it would be written like this, plus 500, or maybe with a more precision, plus 500.00. These levels with plus signs are commonly referred as meters above sea level, ASL, though technically it's above ordnance datum, AOD. This is what the responsible surveying department of a government has decided is zero. Usually this is different in different countries. Usually it means that it's zero means as a mean sea level. Just know that different countries and even different part of the same country can have a different ordnance datum. The London subway system on the drawing has -100 as its starting point to avoid the awkward and easily miscalculated range around zero. Like +1 to -1, that's a 2-meter difference. That's beyond the scope of this video, but just know that, and preferably remember to ask if you're changing working sites what the ordnance datum is, or at least try to remember that zero is the sea level. Try to visualize that. Here's a drawing of a real-world example of a parking lot. Here's the entrance, and here's some parking spaces. And look at these numbers, plus 53.47, plus 53.20. That would be, it's about 53 meters above sea level. These are called spot heights. Spot heights. That's the important term. And this is to signify that these are absolute levels. Sometimes I might be referring them to as plus heights, just because the simple reason that there's a plus sign in front of them. So this spot height is higher than this spot height. And if we would drop a drop of water here, virtually on the drawing or in the actual parking lot, it would flow like this. It flows to the lower part. So this is just to signify that this part is higher than that. Is this confusing? It might be, if you've been using lasers but only used it for relative heights before. What is up and down? Sometimes you get confused about, is it the rod we're talking about? Is it the ground we're talking about? Well, from now on, forget what you've been thinking about before. Just remember that we are always talking about absolute levels. If we say go up, that means that the ground is going up. If we say go down, that means that the down has to go lower. We have to cut on the ground. Here's another illustration, just to make it easier visually, to think of a thermometer. Say here's a thermometer, and plus 20 degrees is naturally higher up than say plus 5, and -10 is lower than -8. And in the same way, plus 20 meters would be higher than 5 meters. That's 15 meters of difference. Another thing that's very important is to always use meters. Spot heights are always in meters, never nothing else. But your staff or rod might be millimeters or centimeters. So it's very important to always, when calculating something, to use meters. Look at this example. Say you have a spot height on a road. And now you add a curb that's 100 mil higher. What's the spot height on top of the curb? And I recommend you pausing the video if you're not 100% sure that you know your answer. Sometimes it's not always easy to convert between millimeters or centimeters to meters if you're not used to it. So what number did you come to? The correct answer is 65.43, since 65.33 plus 100 mil is the same as adding 0.1 meter to the number. So a common mistake, especially in the beginning, is something similar to this, when you haven't added the decimal points in the right place. Here's some more worked examples. Here's an example for road. The top of road on this particular spot is, say, plus 10.25, and the road build-up is 450 mil. What would the sub-base level be on this spot? Well, you take the spot height on top of road plus 10.25 and subtract 0.45 meters. That is 45 centimeters or 450 millimeters. If you punch that in your calculator or do some mental calculations, that's 9.8 meters. Here's another slightly harder example. Think of a manhole, and you have a cover level here, 73, and an inlet where the pipe is at, where the water flows at. That's, say, plus 72.0. And it's a catch pit with a 300 mil drop inside, and you have a base of 150 millimeters of concrete. What would the excavation level be? That is to mean the bottom of concrete. Once again, this, if we add these numbers together, 300 mil and 150 mil between the invert, that's 0.45 meters lower than the invert, so the total calculation would be 72 minus 0.3 minus 0.15, and that is equal to 71.55. That would be the excavation level. And I hope you found this guide and section useful, and if you don't remember anything else, remember this: always use meters in your calculations, you can't go very wrong then. And remember the illustration about the mountain or the thermometer. When using absolute numbers, a higher number is higher and a lower is lower. Thank you.